All right, let's go on a bit of a cosmic journey, shall we? We're on the hunt for another Earth. Over the next few minutes, we're going to tour some of the most promising worlds humanity has found so far and get real about the incredible challenges we face in our search for a second home.
It all really boils down to this one massive question, right? It's the big one. This is what drives astronomers to peer into the deepest, darkest corners of space, just looking for those tiny glimmers of hope around faraway stars.
So where do you even start looking? Well, the search is pretty much laser-focused on what scientists call the habitable zone. You've probably heard of it as the Goldilocks zone. It's that cosmic sweet spot. Not too hot, not too cold, but just right for a planet to have liquid water, which, is a pretty key ingredient for life as we know it.
Okay, our first stop is practically in our own galactic backyard. We're heading to the star system closest to us to check out a world that got everyone, and I mean everyone, incredibly excited: Proxima Centauri b.
It's just 4.2 light-years away. Now that might sound like a crazy long trip, but on a galactic scale, that's basically like waving to your neighbor across the street. Its proximity is what makes it so important.
And that's really the headline here. Being the closest means it's our #1 target for study. It's a real, tangible world that we can actually look at in detail, not just some faint dot trillions of miles away.
But here's where the drama kicks in. On the one hand, Proxima Centauri b is right in the habitable zone. It checks that huge, all-important box. But on the other hand, its parent star is a really volatile red dwarf. It's constantly blasting the planet with intense radiation that could literally just peel its atmosphere away like an onion. It's the ultimate cosmic cliffhanger.
Okay, next up, we're going to jump a little further out to a system that caused a massive stir a few years back. Not for one, but for a whole family of potentially habitable worlds. Welcome to the TRAPPIST-1 system.
So now we're about 40 light-years from Earth, hanging out in the Aquarius constellation. And this is the home of the truly remarkable TRAPPIST-1 system.
What makes this place so special is its star. It's an ultra-cool M-dwarf, way smaller and dimmer than our Sun. And orbiting it is this tightly packed family of 7. Count them, 7 rocky planets. Just an unbelievable find.
Now get this. Of those 7 planets, an astonishing 3 of them are in the habitable zone. The real star of the show is TRAPPIST-1e. We think it's the most promising because its size and density hint that it could be a rocky world, a lot like our own. But then you've got 1f and 1g right there with it, making this whole system a total treasure trove of possibilities.
But, and you probably saw this coming, just like with Proxima Centauri b, there's a major catch. This incredibly promising system is up against the same fundamental threat.
And yep, here we go again. Radiation. M-dwarf stars are known for being prone to violent flares, and since these planets are orbiting so close, they're just getting constantly bombarded with high-energy particles. The huge question is, have they managed to hold on to their atmospheres, or have they been completely scoured clean over billions of years?
All right, for our last stop, let's look at 2 very different trailblazers. They really show us that the search for another Earth isn't just about finding an exact copy. It's about figuring out all the different ways a planet could possibly support life. First up, let's talk about a planet that absolutely made history. This is Kepler 186f, a real pioneer in the whole exoplanet game. This was the one. 500 light-years away, this was the discovery that proved it. It proved that Earth-sized worlds in the right spot weren't just science fiction. They're actually out there, just waiting for us to find them. Now, it is on the cooler outer edge of its habitable zone, but its size strongly suggests it's a rocky world. Now let's switch gears and meet a completely different kind of contender. This is LHS 1140b, and it gives us this tantalizingly different picture of what a habitable world could look like. So, LHS 1140b is what we call a super-Earth. That just means it's bigger and more massive than our planet, but it's not a gas giant like Neptune or anything. It's likely a dense world, maybe rocky, maybe water-rich.
And this is why scientists are so excited about this one. They think it might be a water world, maybe covered in deep oceans. Even better, recent data suggests it doesn't have a thick, life-crushing hydrogen atmosphere, which is a huge green light for its potential to host life.
So you see, what's really important is that we have these 2 totally different paths to habitability. On one side, you've got the rocky twin, like Kepler 186f, a world our size. And on the other, you've got the water world, like LHS 1140b, a bigger planet that could just be teeming with life under its waves. We're not just looking for one type of needle in this cosmic haystack. So, after visiting all these incredible worlds, where does that leave us? What happens next? Well, this is where our little tour wraps up, but believe me, the real journey is just getting started. The thing to remember is, these aren't just drawings or fantasy worlds. They are real destinations for our most powerful telescopes. Right now, as we speak, the James Webb Space Telescope is staring at worlds just like these, trying to sniff their atmospheres for the chemical fingerprints of life. And honestly, what we've talked about today is just a tiny, tiny fraction of what's out there. We've confirmed over 4,000 exoplanets, with thousands and thousands more just waiting to be confirmed. We are living in an absolute golden age of discovery.
Which brings us to the final and most thrilling question. With all these worlds to explore, where do you think we'll find life first? Is it going to be on a rocky world just like ours, or maybe a massive water world totally unlike anything in our own solar system? The answer is out there, just waiting.